presentation that is too long for the time that we have, so I'm going to go fast. If you want me to slow down or stop, or you have questions, just tell me, reach out. But I'm looking around here, and I was trying to figure out a way that I could bridge the age generation here, age gap between myself and you guys. I'm 42 now, but in 1988, I was probably about the age of some of you guys. I was 16, 17 years old, and this is actually what I was doing. So I was a sponsored rider for Burton Snowboards, and I was a snowboard racer. So not really tricks as much like everybody does today, but more like the precision kind of alpine thing. And so for me, when I was your age, this was my focus. And I didn't really know how something like this could translate into a career, right? Because snowboarding wasn't in the Olympics or anything like that, so it's not like anything that, was a guaranteed path. And so for me to figure out a way forward from this, I needed to try to think about what my interests were, right? Really my interest, to be honest with you, I loved sculpture, I loved creating shape, and so like this thing on the left, we'll refer to this as form, and that was like, I just loved the act of like creating something with my hands and having it kind of have a visual message. But at the same time, I completely love race cars, and I was just totally obsessed with racing and the kind of function that comes with a race car. So like if you look at a race car, everything that's on there is on there for a reason. All the wings and the little flips and everything, they're all doing something. There's a function to them. And so there was form. I had an interest in form and an interest in function, and I didn't know really how those could kind of come together. And I have to credit my dad actually with, he never really told me what to do, but he did say, hey, the combination of what you love is design. And so it is actually the combination of form and function. And so that's really when I started to understand maybe what I kind of wanted to do. And actually then went to Carnegie Mellon University in Pittsburgh, Pennsylvania. Graduated in 1995. And soon after came straight out to DesignWorks, which is owned by BMW here in Newbury Park, California, up northwest of LA. And I've basically been there ever since. And one of the things which I got exposed to really quickly, this was one of the first projects that I worked on. I wasn't the primary designer, but I did work on it. And so I knew about form and I knew about function, but this project taught me about the idea. So the idea here is that, well, why are cars made out of metal? Why is the exterior metal or carbon fiber or fiberglass or anything like that? Why couldn't it be something different? Because carbon fiber or metal or tooling for anything like that is extremely expensive. So what if the car was actually made out of something that was flexible, and it could move sort of like a body moves, right? And so you have like bones underneath and a skin on top, and so things would just flex and move on this car. And so that kind of kinematic surface was really interesting to me, and that was like a pretty cool first exposure at DesignWorks. But at DesignWorks we also work on a whole kind of range of design, and so we do work that's like product design. So like this computer on the left, it's kind of a conceptual computer, CPU. Also things like just basic furniture, construction equipment. We also design BMWs. That's the new i3 that's just coming out. This was like one of the first sketches for it, which is an electric powered car that's just hitting the road now. And then also really what you would see on the screen. So for example, all this graphic design and interface design of how you use your phone or a computer or anything like what you see on a screen, that stuff's all designed. And so those are things that we do on a regular basis. This was my next project really. after the Gina project, which was a Formula BMW race car. And so this was my directive, or what I was told to do, was to make it look like a BMW. Right? So it's a Formula car, but it has some of these elements like that support the front wing. It's kind of like those what they call the kidneys on BMWs, and some of the wings and the way that the surfaces are cut and things like that was meant to have a similarity to. Yeah, you got a question?
Yeah, why did Sauber drop out of F1?
Sauber's still in F1, but BMW dropped out of F1.
Okay.
And it's incredibly expensive. I think that's probably the biggest reason. But it was interesting, like on this project, Sebastian Vettel and Nico Rosberg, they all started driving race cars. Like they started in this series. It was like one of the first automotive series that they ran in. So it was pretty cool. Like I sat next to Sebastian Vettel when he had big, huge braces, and he was a really awkward looking kid. But anyway, so that was a cool one. My next project was this BMW H2R, which was a hydrogen-powered world speed record car. And we set 9 world speed records with this car, and with hydrogen power, including going 302.6 kilometers an hour. And so the purpose of that was to show that hydrogen could not only be clean, but it could also be really fast. And it could do what you expect a BMW to do, as well as be incredibly clean. And then the next project is probably the most recent, and maybe some of you guys have seen it, but it's the two-man bobsled for the US Olympic team. And for me, it was probably my favorite project ever to work on. I thought we might be able just to take a really quick case study and look at the steps at how you get through a project like this. But before doing that, let me see if I can just play a quick movie. If I can get this to work. That doesn't want to play. So this is just a 1-minute trailer that NBC put together for this project.
Every 100th of a second is 100th that much closer to a medal, or 100th that much further away from a medal?
If you look at the last Olympics in Vancouver, second and third place were separated by 1/100th of a second.
That's the difference between winning medals and losing medals.
Last time I won a gold medal was 1936 in the two-man bobsled.
We needed to find the next level of sled. We approached BMW and we cut their understanding of what makes something go fast.
First bobsled for BMW, first bobsled for me.
Do we have enough time to dial these sleds in?
Oh, straight into the wall.
I couldn't steer.
With this new bobsled, we can win a gold medal.
I can't wait to get to Sochi.
Very cool.
So that was actually a trailer for a 30-minute documentary that NBC did on the project, which was pretty cool. Not all projects are like that, I can tell you for sure. Just a quick case study to show you kind of the basic steps. So we already did that, but really the first step is to get in there. You need to understand how these sleds are used, what the athletes are experiencing when they go down this track. And so the first thing I did was fly to Lake Placid, New York, and I stepped out of the rental car, and the team greeted me just kind of casual, like, yeah, hey, how's it going? Shook my hand, and I just said, you know, get in. And they put me straight into a 4-man bobsled. That's Kurt Tomaszewicz right there with his back to us. He's an Olympic brakeman. And I sat right in front of him, kind of in between 2 professionals. And we went down this track, and it's the most violent, brutal thing. I thought I was ready for it. I thought I had raced cars all my life, and I'd snowboarded and done all this stuff. I thought, yeah, it's going to be cool, it's going to be fun. And it was the most horrifying, terrible experience I've ever gone through. They do 5 Gs in the corners, which is, you know, basically your own weight times 5. So you know, that kind of loading and the vibration is just incredibly severe. It is an extreme sport. But from that experience as a designer, really what your objective is to try to find opportunities. So you go through that horrifying experience, but like, how could you improve it, right? And so the first thing you start doing is, once you've had those experiences, you need to think about ways of improving that situation. And so you just start sketching or thinking. And so these sketches are super loose, sloppy things, right? They're not beautiful sketches like everybody thinks comes out of a designer right away. It's never like that. And so, for example, just to give you a quick, like this is one of my sketches here on the left, just a very quick kind of scribble that happened really quickly. And then the way of kind of tightening that up into something that's more precise is to then take it into Photoshop and just use Photoshop as like a rendering tool where you can put in a shadow and a highlight and you can start to describe the shape a little bit more accurately. But then from there you go into a true computer model. And we use Alias as a software to create incredibly accurate shapes. And with those shapes, they all had to fulfill a very precise set of measurements because the regulations are very, very strict in bobsledding. But what we did was create a family of 5 shapes, so 1 for each color of the Olympic rings. And so we needed to understand what the potential of each one of these shapes was from a performance standpoint, because we'd never done a bobsled before, but we wanted to make sure we understood why they were shaped the way they were. So you can see with them overlaid, all these models, there's this huge difference in all the things that we tried. Some have the nose up, some down, all kinds of things, but you can also see common points where they all have to fulfill the same regulations. But really, to understand the possibilities of those shapes or the potential of those shapes, you have to test them and understand what kind of performance they deliver. And so we use what's called computational fluid dynamics, which is basically like a wind tunnel in a computer. So you could take this shape and you can understand its performance capabilities from a lift standpoint, which is an upward force or a downward force, and then a longitudinal force, which is the drag. And in bobsledding, the drag is the most important thing. You want to get that as low as you possibly can. And so the cool thing about computational fluid dynamics also is that it allows you to see how the air is flowing over a shape. And these colors, where it's green, that just kind of means like it's neutral. It's not really being affected that much by the shape. But where it's red or orange is like a high pressure zone, and where it's blue is a low pressure zone. And so that's something that actually creates drag typically. And so it's good to be able to see exactly where that's happening and measure the performance of a shape. And so that's something that we use all the time. So in that runoff, basically the black family was the winner. And from there, we did 69 iterations of the shape. And so when I say an iteration, that means you model a change, and then you send it off to the CFD testing, which takes all the way overnight. And then you come back in the morning and you get your results, and then you make another change, and it's kind of like lather, rinse, repeat shampooing, right? Yeah, question?
What would be an example of a change that you would make to one of these iterations?
Sure. So, say for example, you see how this bumper is kind of slanted down at the back? You know, that has an impact on what is happening with this flow. You can see the flow kind of dipping over it. So we would then, like, let's say, put the bumper straight up and then run it and see what that means. Because if you change like the whole side of it, you wouldn't know really what created that effect. So you have to keep the changes kind of small so that you know what they're doing as you go, and you keep track. You have to keep very accurate track of changes. So if you were to totally change the thing radically, it might be better, but you wouldn't know how you got there, and it's very important to know that. So 69 of those, we ended up with this shape. And this was our first prototype. This was basically the data for making our first prototype. And so this was all created on the computer. These are kind of beauty shots of it, of the data rendered, and then just in Photoshop I put in the background. And this was sort of how we knew what it would kind of look like before it came out. But really the way that you truly know what you've got is to actually mill it. And you use that data to then use this huge milling machine to carve out the shape. And so this is a big, huge block of foam being carved out by this machine, which is translating the data that was created into a three-dimensional reality. These are some of the more mechanical parts that you can also machine from the data that you create on the computer. But ultimately the purpose was to get it on track. And this was in Park City, and it was our first opportunity to understand how everything worked, because honestly, you can do as many simulations as you want. You can run these CFD simulations over and over and over, night after night after night, and you can kind of get close, but you really never really understand what you have until you get it onto the track, because a bobsled track is shaped so diversely, and it's either climbing a turn, it's in a turn, it's coming off of a turn, it's banking, it's doing all these things, it's vibrating, but there's no way you can simulate all of those things, so you have to get it on track to get your answers. The cool thing about also making a three-dimensional true sled is that you could then get the athlete's feedback on how does it fit? Do the handles fit where I want to be? Are there any speed advantages that we can find in the way that the handles are shaped, for example? We could also scan the athletes in position, which is pretty cool. It's like a full body three-dimensional scan. So now we know exactly where we can put things in the sled that would not interfere with the athletes, but we also know the aerodynamic contour of the back, the rear guy's back, which is incredibly important for the aerodynamic performance. This is my favorite picture from the whole project. It looks like this guy's wearing a Batman costume, right, because of his muscles. He's not. He's like 6'5", and this is your typical looking designer who's like a perfectly concave chest, right, compared to this guy, which is just totally a different species.
Desk job.
Yeah. We also could go to the wind tunnel, which was actually down here in San Diego, and compare those results with the CFD. And from those, we did another 78 iterations of the shape to try to get it exactly what we wanted it for the Olympics. And so the gray shape here is actually the new shape. The pink one is the old one. You can see the gray one's much smaller and almost fits inside of the pink one on the whole front. And then we changed the location of the bumpers and all those. And it's also, the gray one's much shorter. And so those were kind of learnings that we took into this final model. And this is the one that went to the Olympics and was also on the World Cup tour for all of the 2014 season. Just the last couple slides. So on the World Cup tour, we won 23 medals during the season. We were the World Cup two-man champion overall. We had 2 complete podium sweeps. That means the U.S. was 1, 2, 3, 1, 2, 3. No other nations, except I should be more specific. With the women, it was 1, 2, 2, because bobsled runs are 2 runs combined, and it's down to the 100th of a second. And the 2 second place finishers tied exactly to the 100th of a second with 2 combined runs. I don't know if any of you know Lolo Jones, but she's the 1 second from the left there in the small picture. And then we went to the Olympics, where we won 2 of the 3 available medals. So we won the silver as well as the bronze. And that was super, super cool. That was, I think, the first time the U.S. had ever done that. And for the men's, we actually made a little bit of history in that for the first time in 62 years, the U.S. won a medal in bobsledding. Wow. And so for us, that was really, truly an honor to be a part of. I was able to be there for that, and that was just incredible to be able to see the project come all the way through to fruition. So that's just a quick run through, hopefully not too quick, on kind of the steps that you do from a design standpoint to actually make something at the end of the day. So I don't know if that's helpful for you guys, but we do that all day long with cars, like that run on the road. We do it all day long with construction equipment, with computers, cell phones. You know, everything that you see or touch ultimately is probably designed in some way. Like the graphic on your T-shirt, somebody designed that, and it's something that is. Some people don't think about that fact that somebody did think about what stuff should look like. So that's what we do all day long.
Cool.
But any questions yet?
How many people were involved with this project?
On the bobsled project? I think at DesignWorks we probably had roughly 7. But I was the consistent one through the whole process, and some people would come in and come out of the project. So like modelers to create the shapes and things like that. And then we also had an engineer with us most of the time. And then the entire US bobsled team, so that's like 20, 30 people. But we were mainly working with the coaches and a couple of the key athletes. So like Steve Holcomb, the guy that won the medal, I worked with him a lot on that, and as well as the coaches themselves. So there's probably like 5 key people from the US team.
Okay.
Yeah.
How long did the whole bobsled project take to start?
It was about 2 years, a little longer than 2 years actually, by the time everything was truly said and done. But most of the content work was 2 years, which is actually pretty aggressive. Like for example, that first ride I took was in October of 2011, and the first prototype we had on the track was in March of the next year. So it's, you know, it's only 5 months, which if you're creating something from scratch is pretty aggressive. And so like when we design a car, it can take 7 years before you start, you know, drawing to something actually reaching the road. And so that's like one of the longest development cycles that you will ever have in any industry. But cars are very, very complex, and the refinement's incredibly important. So that's why it takes that long. Yep.
Was that BMW G-Nub with the like flexible?
Yeah.
Was that ever released?
Yeah, it was a show car.
Okay.
So it made like a whole circuit of appearances, and there's some movies and stuff with it that have been made that show like all that kind of movement and functionality of like the door kind of swings open, and you know there's no like cut line in the body side. It's just the material just kind of like a chicken wing, and it's pretty cool. I like projects like that are fun because you have to have the idea, right? It's not like, oh, let's just make something cool looking, or oh, let's just make something fast. Like you have to have an idea of something different, and that's the hardest part, I would say, of design. It's like, yeah, some people are really good at making beautiful things, but the idea behind, like, what's next? What, you know, why is something the way it is, and maybe it could be different. That's the hardest part, and I think it's the hardest part to get kind of trained for. But it has a lot to do also with what kind of school you go to for design. You wouldn't take any other classes. You wouldn't take English or history or any of those things. But my belief is that design schools that do include other disciplines and other classes are better, because you learn about other things, and you learn how to think, not just about design, but you think about the world. And that's kind of the whole point, is to be able to make the world a little bit better, hopefully, with your solutions. Yep.
At what point in your life did you know that you wanted to pursue a career in design?
Yeah, I was mentioning this right before. Like when I was snowboarding and stuff, when I was in high school, when I was your guys' age, I didn't know. And I know that that's like a kind of scary thing, right? And I was lucky because my dad was an architect, and he was familiar with design, but he was really the one that kind of pointed out the obvious to me at some point, where it was like, you know, you're really interested in sculpture, and you're really interested in race cars. you could sort of put these together. And I think I was probably 19 at that time. Once I realized that, it was like full tilt. I've never worked harder in my life, still to this day, and got into a really good school and did really what's needed. But I knew that was my one chance because, you know, if you wait too long, yeah, sometimes you miss the train. But it's a good question, and I think for you guys in particular, you know, I think in one way it's sort of unfair to know what you want to do so early, but some people do, and some people just know that from the beginning, and that's what they want to do, and it's great to get such an early start, but it's also okay to be a little bit curious and unsettled, because that's kind of natural. You need to find your own fit.
Was it unusual to get such a good job right out of college like that, or did you have a super resume in college?
I got the job at DesignWorks BMW because I raced cars. I had a good portfolio. I had gone to a really good school, but somehow your personality needs to come through, like, because there's lots of people that have really good portfolios and went to really good schools, and so. Part of my portfolio was the fact that I had interned with a race car manufacturer during college, and he was a kind of a one-man show. Like, he designed and built and raced these really cool cars, and I had that as part of my portfolio because I went and I worked for him for free for many months. Like, every spring break I had, I would be there. Every summer break I would have, I'd be there. Every Christmas, everything, I would go and I'd work for free, and it was really intense and kind of brutal, but that is sort of, you know, a very formative experience and made an impact on me. So my portfolio had a reference to my racing, and the guy that was running DesignWorks at the time loved race cars, and he was like, yeah, get that kid in here. Sure, let's give him a shot. And it was because I had a personal interest in something that he had a personal interest in. It just so happened that that's why he brought me in. And so from that was 18 years ago, but and I've managed to work on race cars, you know, since then, but not every day. You know, it's like every 4 years a really cool one kind of comes along, it seems like. But yeah. Sorry, you're next. What's up?
How did you get into racing, and then what discipline did you race in?
Yeah, I raced road racing, so SCCA mainly, but there was pro series as well as amateur series. Like that race car that I showed at the very beginning.
The black one.
Yeah, that's me. And that's a car that I took to the national championships in 2010. I got into it just because I absolutely, you know, loved it as a kid, and always sort of was fascinated by the engineering behind it, but also the driving of it and the forces and the sensation that you feel, because the downforce that something like that creates is so high that it takes you into places that you shouldn't be able to go, you know, physically, you know, and it's another kind of world of performance, which I really loved. And so for me it was important to try to stay involved with something like that. But I got into it, yeah, roughly 18 years old, so I was kind of late for most.
So did you have to like start karting and then you got into that?
No, I went straight into cars. I wish I had started with karting, but the kids that started in karting are way better. You know, they just start so much younger. So I started at 18, and I was too tall and too slow. But yeah.
Is there someone that you look up to in your career in your life?
Yeah, that guy that I went to work with, the race car manufacturer, the kind of one-man band, he was like the nastiest, meanest guy you've ever met. But he was incredibly good at what he did. And so I really looked up to him for that, just based on like the content. But the other person I looked up to is actually this sculptor. On the left, this sculpture was done in 1912, believe it or not, like ages, and you know, more than 100 years ago, right? But the sculptor, his name was Umberto Boccioni, and he made these incredible shapes, and this is just one of them. And so he was somebody that I always really looked up to, and trying to combine those worlds of interest is really how I got to where I am now.
Thank you.